Hello, dear colleagues. My name is Alex. I'm Alexander Popov student, and we study mechanical engineering in St. Petersburg, Peter the Great Polytechnical University. And today I made a video for you about turbines. So let's have a look.
So, let's begin. What does a wind wheel standing on a sandcastle have in common with a massive ocean liner and hydroelectric dam or transatlantic jet? Answer: they all use turbines, machines that capture energy from a moving liquid or gas. Let's take a closer look at these handy machines and find out how they work. The key parts of turbine are a set of blades that catch the moving fluid, a shaft or axle that rotates as the blade moves, and some sort of machine that's driven by the axle. In a modern wind turbine, there are typically three propeller-like blades attached to an axle that powers an electricity generator. In an ancient water wheel, there are wooden slats that turns the water flow under or over them, turning the axle to which the wheel is attached and usually powering some kind of milling machines. So, the turbines have two ways of work. Let's take a close look. First one is the impulse turbines. In an impulse turbine, a fast-moving fluid is fired through a narrow nozzle as the turbine blades. To make them spin around, the blade of impulse turbine are usually back-shaped, so they can catch the fluid and direct it off at an angle or sometimes even back the way it came. In an impulse turbine, the fluid is forced to hit the turbine at high speed. The other way is a reaction turbine. The blades sit in a much larger volume of fluid and turns around as the fluid flows past them. A reaction turbine doesn't change the direction of the fluid flow as drastically as an impulse turbine. It simply spins as the fluid passes through and past its blades. Wind turbines are perhaps the most familiar examples of reaction turbines. Broadly speaking, we divided turbines into four kinds according to the type of fluid that drives them: water, wind, steam, and gas. Although all four types work in essentially the same way, spinning around as the fluid moves against them. They are subtly different and have to be engineered in very different ways. Water wheels will date back over 2,000 years to the same time as the ancient Greeks were the original water turbines. Today, the same principle is used to make electricity in hydroelectric power plants. The basic idea of hydroelectric power is that you dam a river to harness its energy. Instead of the river flowing freely downhill from its hill or mountain source toward the sea, you make it fall through hay. So it picks up speed, then channel it through a pipe called a penstock, past a turbine and generator. A turbine like these ones is a wind farm. It's a machine that spins around in a moving fluid. It catches some of the energy passing by. All sorts of machines use turbines, from jet engines to hydroelectric power plants and from diesel railroad locomotives to windmill. Even a child toy windmill is a simple form of turbine. Steam turbines evolved from the steam engines that changed the world in the 18th and 19th century. A steam engine burns coal and opens fire to release the heat it contains. The heat is used to boil water and make steam, which pushes a piston in a cylinder to power a machine such as a railroad locomotive. This is quite inefficient for a whole variety of reasons. A much better design takes the steam and channels it past the blades of a turbine, which spins around like a propeller and drives the machine as it goes. Airplane jet engines are just a bit like steam turbines in that they have multiple stages. Instead of steam, they're driven by a mixture of the air sucked in the forefront of the engine and incredibly hot gases made by burning huge quantities of kerosene. Somewhat less powerful gas turbines engines are also used in modern railroad locomotives and industrial machines. You might have noticed that wind turbines look like giant propellers, and that's another way to think of turbines. A propeller working in reverse is an airplane. The engine turns the propeller at high speed. The propeller creates a backward moving draft of air, and that's what pushes propels the plane forward. With the propeller, the moving blades are driving the air. With the turbine, the air is driving the blades. So, that's all, my friends. Thanks a lot for watching. Goodbye.